Hello, welcome again. We are solving some questions of theory of machine. The topic is vibration. Question number 60 from GATE 2014 ME-01 is: a rigid uniform rod AB of length L and mass M is hinged at C such that AC is equal to L by 3 and CB is equal to 2L by 3. The ends A and B are supported by springs of spring constant K. The natural frequency of the system is given by. So this is a spring. These are the two springs of stiffness K and K, and this AC length is L by 3, and this CB length is 12 by 3. So we have to find out the natural frequency of this system. So options are root K by 2m, option B, root K by m, option C, root 2 K by m, and option D, root 5 K by m. So to find out the natural frequency of the system, let us displace the rod by an angle theta in clockwise direction. Or this is the instantaneous position of the rod at an angle when it is vibrating at an angle theta. Okay. So when theta angular displacement is given to that AB rod, then this spring will extend and this spring will compress. So the extension of this spring will be your uh, radius into theta, or arc, or it will be 2L by 3 radius into theta, that is 2L by 3 theta. Similarly, the extension of this compression of this spring will be radius into theta, that is L by 3 into theta. Okay. So now we have compression, expansion of the spring and compression of the spring. So now we can determine spring force. So as expansion of the spring is 12 by 3 theta, and uh, so the spring force will be K into 12 by 3 theta. Okay, that is in upward direction. Okay. Similarly, the spring force for spring 2 will be in downward direction, that is K into L by 3 theta. Okay. So it is in downward direction. And now we have considered spring forces. So this is a dynamic problem where the rod and springs are vibrating about C. Okay. So now to convert the dynamic problem, we will convert the dynamic problem into static problem. We will apply the inertia torque or forces where whatever is the problem. So as this is a problem of angular displacement, so we will apply inertia torque. So suppose I1 be the moment of inertia for this portion. Okay, and I1 theta double dot is the inertia torque for this portion. Okay, or like this. Okay, and it will be in a direction opposite to the displacement of the angular displacement of the rod. Okay, so as it is in clockwise direction, so the inertia force for this portion will be inertia torque for this portion will be in counterclockwise direction. Similarly, for this portion, uh, this it will the inertia torque will try to bring back this rod into its position, because I2 is the moment of inertia of portion AC, and theta double dot is the angular acceleration. So inertia torque will act in this direction. Okay. So now the various forces and torque acting on the system are: spring force on spring 1 is just K into 12 by 3 theta in upward direction. Spring force on spring 2, K into L by 3 theta in downward direction. Now an inertia torque on rod CB, that is I1 theta double dot, and where I1 is the moment of inertia of portion CB. So as total mass of the rod is m, so for 2/3 of length, the mass will be m into 2 by 3, because it is uniform rod. So mass is m into 2 by 3. Okay. So that is the mass of the portion CB, and it is rotating about or vibrating about this portion. So we'll take moment of inertia about this portion, and for this moment we'll multiply mass of this rod with the length of this rod, that is 2L by 3 square divided by 3, or general formula is ml square by 3. So here m is m into 2 by 3, and l is 12 by 3 square by, okay, and divided by 3 I will be moment of inertia. So this is the moment of inertia of rod CV, and I2 is the similarly uh, for this the inertia torque will be I2 is equal dot, and in the similar way the mass of this portion will be m by 3 and length is l by 3. So I2 will be m by 3 into l by 3 square divided by 3. Okay, so I2 theta double dot is the inertia torque of the rod reaching counterclockwise direction. So now taking moment about C, so that will be I1 theta double dot plus I2 theta double dot uh, plus k into 12 by 3 theta into L 12 by 3 and plus KL k into L 3 by into theta multiplied by I by 3. So it will be I1 theta double dot k into 12 by 3 theta, that is force, and that force is causing clockwise movement, and I1 theta double dot is also clockwise, so multiplied by length 12 by 3 theta and plus I2 theta double, that is clockwise, and KL by 3 into theta is your spring force and L by 3 is the distance, and it is causing clockwise movement, so it is also positive. Okay, so now we can we can separate the coefficient of theta double dot and theta. So coefficient of theta double dot is I1 and I2, and coefficient of theta is k 4l square by 9 plus l square by 9. Okay, is equal to 0. Okay, so I1 is I1 is this quantity and I2 is this quantity, putting the value of I1 and I2. Okay, uh, so we get the coefficient of theta double dot as solving it. Okay, solving it, and we get we get the equation as ml square theta double dot plus 5l square k theta is equal to 0. Now omega n is coefficient of theta divided by coefficient of theta double dot root, so that is 5k by m. So option D is the right answer.